So another useful Java keyword is final. We use that generally to define constant values. So strictly speaking, final fields are not actually constants because they can be modified, but only once, and any modification must be performed before the class constructor finishes. So what that means is that we can assign a final field its value either when we first declare it or in the constructor. So as an example, we'll create a test class here. We'll just call it SumClass. SumClass. So we can create a final variable here, and we can create the final field. So private final int instance number equals 1. So I can do it in there. Just tidy that up a bit. We can also do it in the constructor like so. We could put something like instant number equals 1. Now both these examples obviously do the same thing. The field instance number is set to 1, and because it was marked final, its value can't be changed anywhere else in the class, or if we made it public from anywhere outside the class either. But in this case, it's usual to assign the value when declaring the field, but if you prefer, you can use a constructor instead. Now, one reason why you might want or might need to initialize the variable in the constructor would be if its value is a result of some calculation, or perhaps relies on some other code, such as a method from another class. As an example, when reading a record from a database, you might want to store the class instance's unique database key, which wouldn't be available until you'd read the record from the database and were then ready to create the class instance from the database field. So we haven't created databases yet, so as a mechanism to show how this would work, what we'll do is we'll create a mechanism for ensuring that every instance of a class has a unique instance number or ID. What this will require is for us to track a variable each time a new class instance is created. So this is an ideal candidate for using a class variable as we saw in the previous lecture. So what we'll do is we'll make instance number public to make it easy to demonstrate that it can't be changed, but normally when doing this you'd make it private. So I'm going to change this now, this public final int instance number. I'm going to remove the initialization, and as I mentioned, I'm going to change it to public. So what we'll also do is we'll have a static variable, call it class counter, set that equal to 0. We need a string for a name, so private final string name. So in our constructor, we're now going to accept a parameter, and that's just IntelliJ complaining that it may not have been initialized, but we'll fix that in our code shortly. So we'll use a parameter for the constructor. This dot name is equal to name, and now IntelliJ is happy on line 10. And we'll increment the class counter because we're instantiating a new version of this class, and we'll set instance number equal to class counter. Then what we'll do is we'll output name created instance is plus instance number. So that's our constructor, and we just want to put a getter there as well. So we're going to put a getter for our instance number, like so. So let's go back now to main and create some instances of this class. So we'll put some class 1 equals new, some class 1, some class 2 equals new, some class 2, and some class 3 equals new, some class 3. So if we run that, you can see, unlike in the discussion of static, where we had a getter for the static field and we always got the same value, whichever class instance we called it on, here we're actually storing the incremented static value in a class field. And so each instance of the class will maintain its own value for instance number, as we can see. So just to demonstrate that, what I mean is we can put one.getInstanceNumber, 2.getInstanceNumber, and 3.getInstanceNumber. So if we run that, and notice how they're all maintaining their own value for instance number now. So by making instance number final, the value, its value can't be changed once the class instance has been created. So attempting to do so will give an error and the code won't even compile. As an example, bearing in mind we set the instance number to a public, one.instance number equal 4, we actually get an error immediately. Cannot assign a value to final variable instance number. So it's actually a good idea to mark variables as final whenever you know that the value shouldn't be changed once the initial value has been set, and a constant value would be an ideal candidate for that. That said though, now you may be used to seeing constant values in Java if you've done some coding before, declared using static final, and that's more normal for constants. So our instance number here, going back to the code, was not being treated as a constant because we did want to assign its value, but we only wanted to assign it once and then we didn't want it to change after that point. And that's also why we didn't use uppercase for the variable name. If you remember from the discussion on naming conventions, constant variable names should be in uppercase. So why are constants declared a static final? Well, the reason is if the value really is a constant and won't change, then it doesn't make sense to store a copy of that in every single class instance. They'd all hold the same value, so it makes sense to store it only once at the class level. So hence values that are constant are usually declared using static final. Now we can see examples of this right throughout the Java framework. One example is in the math package. So if we go back to our main method, and I'll just comment out that error, we can do something like print out math using the Java math library.py. Notice pi in uppercase there. And if we just hover over that and have a look, public static final double pi, you can see there, and then it's obviously got the value of pi. So it's declared as a public static final double. So it's usual to assign the value of static field variables at the time they are declared, but again, they can be done afterwards in a similar manner to non-static final fields, and we'll see that shortly. First though, we'll stay with the math class because we want to have a look at another use of final. So what we'll do is we're going to just make a little bit of a change here to create an instance of math so we can do some sums. So we're going to type after that line, math m equals new math. Oh dear, unfortunately that doesn't work and we get the error. Math has private access in java.lang.math, so we just hover over that. So if we right click on that now to go to the class declaration, you can see there's actually a comment above the code and it says don't let anyone instantiate this class. And so the reason we're getting that error is the constructor has been marked private, and that's to prevent, as you saw in our code, instances of it being created. And the reason they've done that in the math class is that all the math class methods are static, fields as well, and they're all available without requiring an instance. So to make that clear and to actually enforce it, the creators of this class, the math class, made the constructor private, and that prevents any instances from being created. Now you might think I can get around that by creating a subclass of math which I can instantiate. Unfortunately, or actually fortunately, creators have thought of this as well, and they stop you from wasting your time by declaring the math class up here as final. So by marking a class as final, applying that to a class, it prevents the class from being subclassed. So any attempt to extend math will fail because it's been marked final. So just to confirm that, try extends math, we're going to get an error. There's no default constructor available. And that's also got to do with the fact that it's currently only got a private constructor. So I'm just going to undo that. The bottom line is though anyway, by marking a class as final, you can prevent your class from being subclassed. Now it's possible that you might want to, or you might wish that a class you're creating to be extended or subclassed, but you might have one or more methods that are crucial to the correct operation of your class that you don't want just those to be overridden. So in that case, marking the methods as final will prevent them from being overridden, even if you do allow the class itself to be subclassed. So just to demonstrate that, I'll close down this math.java now, and we'll create a new class. We'll call it public, we'll call it password. I'll just close down the run window. So let's firstly create a static final int key. Key equals 748576362, could be any number. Private final int encrypted password. We'll create a constructor and we'll pass the password in. But what we'll do is we'll also have an encrypt function. So the password will come in just as a password, unencrypted, and we would write a function to encrypt the password. So I'll write a generic function that would encrypt or decrypt, and then save it into the encrypted password, which is encrypted at that point. And we'll just do something really simple there with the encrypt decrypt. This is just an example, private int encrypt decrypt, accepting a parameter of the password, and we'll just return password key like so. And that's using an XOR to XOR the values there. Okay, and then we'll store the password. So we need another one with public void store password. Saving password as this dot encrypted password, encrypted password. And then we will test in to confirm or to check whether the password is valid. So we're going to type public boolean let me in, which accepts the password as a parameter. Then we'll put if encrypt decrypt password is equal to the password on file. Then we'll print some sort of welcome message, welcome, return true, else, nope, you cannot come in, return false. And that should be up there. I didn't change that should be just password. We're passing the unencrypted password to the encrypt decrypt method. So the encryption, as I mentioned, is a very basic XOR, which just checks the bits in the two values and returns a 1 in any position where there is a 1 in only one of the values. So if you apply the XOR operation to the result, you get back your original value. It does have applications in the field of cryptography, although used in a much more complex manner than what I've done there. So in main, we go back to main now, and I'll get rid of the other error. I'm going to create a new password instance and then call store password. So we're going to put password equals 674312. And we'll put password equals new password, PW. Then we'll put password dot store password. So if we run that, saving password as 747992050, and of course that's completely different to the number that we passed to it. Now this is an example of why you'd want to prevent one of your methods from being overridden, not as an example of how to encrypt passwords for storing in a database. So cryptography is a very complex subject, and I would strongly advise you to use an existing cryptography library if you ever really needed to encrypt passwords or anything else for that matter. By all means, write your own cryptography library once you've completed a PhD in the subject, but until then, don't be tempted. Trust me on this one. So anyway, getting back to our example, the constructor, going back to our code. So the constructor takes the password and encrypts it, as you can see, and encrypts it, setting a field to store the encrypted value so that it can be checked when the user attempts to log in. So let's call the let me in method with a few passwords to check to see whether it's working. So going back down here, now main. So we stored the password, but now let's see if we can get in. So password dot let me in 1, password dot let me in 523266. And just to make this a bit easier for copying, we'll try another one. 9773. Try another one, maybe 0, -1. Then we'll do our correct one at the end, 674312. So if we run that, we should get an error on all of them other than the last one. Nope, you cannot come into the first 5, and then the last one, welcome. We're able to get in because we specified the right password. So you can see that worked, and the last example correctly logged us in. The first 5 entries, first 5 passwords we tried all failed. But the problem actually comes if someone overrides the stored password method in a subclass. So I'm going to end the video here, but in the next video we'll extend on from that and talk about the problems, and we'll actually create a new class that extends from this one and show you how to get around the issues that will come up. So see you in the next video.